Here's an example of taking complex roots. What are all the sixth roots of 1/8? Well, I've got a picture set up for this, and I actually had to do a little bit of the problem before I set up the picture, but let me just give you the idea. I've got the point 1/8 is about 0.125. It's right here on the positive real axis. And I drew a circle at that radius because that's all the complex numbers with that same magnitude. And then what I've got here is I figured out the radius of a circle for all the points so that when I take the sixth power of that, it ends up on the circle that I want. And I'll talk about it in a minute how I did that. Okay, and I just wanted to illustrate how the six powers work once again. It turns out that this real number, we'll figure out what that is in a minute, that's a real number whose sixth power is exactly the real number 1/8. As I go around with z, just 1/6 of a circle. What is that? So that's 60 degrees. Z to the 6th comes back again. Getting pretty tongue-tied here. If I go another 60 degrees, pi over 3, then z to the 6th comes back again. If I go another 60 degrees, oh, hey, that's a negative number. Okay, so that's going to give you a plus or minus. And again, there's going to be 6 different answers to this problem. Okay, so now how do we actually do it? Well, first we put 1/8 in polar form. This is the big payoff for that idea. 1/8 is going to be, well, that's pretty easy. The magnitude is 1/8 and the angle is 0. I'm going to do this in degrees. Radians are kind of more elegant in a way, but I think degrees are going to be a little more friendly. Okay. So now I am just going to take the sixth root of the magnitude. That was weird. Okay, I'm going to take the sixth root of the magnitude. So my r, my desired r for the roots is going to be 6th root of 1/8. Now I picked that to give us a little practice. What is that? Well, the 6th root of 1 over something is 1 over the 6th root. We need all the practice we can get on this. Does that simplify? It turns out it does, because that's the 6th root of 2 cubed. Okay. So in other words, a 6th root is like a cube root and a square root combined. So it's the square root of the cube root. Well, the cube root just gets it down to 2, and so it's going to be 1 over square root of 2. Okay, so that's something that can happen in some of the more complicated examples. And 1 over square root of 2 is approximately 0.707, and that is how I made this circle. So I know that the magnitude of all my mystery z's, they all have to be the same, and the magnitude has to be 1 over root 2 in order so that the magnitude of z to the 6th is going to be 1/8, 0.125. Okay, so now we divide the argument by 6. Well, that's really easy. Gee whiz. 0 over 6 is 0, right? 0 degrees. Isn't that just the answer? Just 0? Well, that's one of the answers, certainly. The real number, 1 over root 2, does, of course, square to 1/8. That's what this calculation really shows. But what are the other ones? How are we getting other ones? We're getting the other ones because we're really looking, this is what we're really doing. We're looking for mystery angles theta. Oops. With 6 times theta, it could be 0 degrees, but there's other ways to represent this point, the angle of this point. It could be 360 degrees. And let's put that all in math mode to make it look nicer. Or, wait, I thought it was going to be in math mode, and I didn't do it right. That's weird. It's just refusing to turn that into math mode. There we go. Okay. Or it could be 720 degrees. Or it could be, whoa, we're getting into really big numbers here, 1080 degrees. Seems like that could go on for forever and ever. Well, let's see what happens when we start dividing by 6. Theta is either going to be 0 degrees, that's the one we already found, that's the real solution of the problem, which we knew already, or 60 degrees, that's this one right up here, or 720 over 6 is 120 degrees, Or, now we can see the pattern. We don't actually have to look at 1080 and divide it by 6. It's easier just to say, oh, I know the pattern here. I'm going up by 60 degrees each time. 180 degrees is this one. That's because we know that minus 1 over root 2. If 1 over root 2 cubed is 1/8, which is what this calculation is about, then minus that to an even power is going to give the same thing. So that's why the 180 degrees works. And then keep going, 240 degrees, and 300 degrees. Now we can see why it stops, because if we just kept going blindly, we'd get back to 360 degrees. Okay. Now, there's a subtle thing here. Why did we have to do 360 degrees here? It's because we weren't actually interested in 6 theta. We were trying to solve for theta. We're trying to find all the z's that when you go 6 times as far around a circle, you get back to where you started. 60 degrees is definitely not the same point as 0 degrees. But if you go 6 times as far, that's what the blue's doing, you do get back. So we had to look at all these points so that we looked at these guys, and it's only when you get back to 360, okay, we can stop there. The other thing you can always know is that there's always going to be 6 answers to this question. There's 6 sixth roots, and so you can just stop when the list is 6. So you don't have to memorize anything particularly about 360s or anything like that. You just stop when you've got 6 answers. Okay, so our polar forms, all our answers are going to be of the form 1 over root 2 cis of all these angles. So let me just write those down. Cis 0, z equals, let me just copy and paste to make it a little faster. Actually, let me copy and paste the whole thing. And that's 6. Okay. So 0, 60, 120, 180, 240. Whoa, not 2400. And 300. Okay. And now we just have to actually see what those are. Well, the first one is just the plain old real number 1 over root 2. Okay. Sometimes these guys happen to be real. And this one was easy. Cis 180, that's the one that's over here. Okay. So that's going to be the minus 1 over root 2. What about this guy? Well, we have to expand it out. What is cis? It's cosine plus I sine. So cosine of 60 degrees is 1/2. And then plus I sine of 60 degrees is root 3 over 2. And then this guy is going to be very similar. Let's see. Any nice things about that? Here's the 60. Here's the 120. Oh, they're just flipped across from each other. We could just calculate cosine and sine, but we could also use that little symmetry. It's going to be minus 1/2. Again, the more straightforward way to do it is just literally you're just plugging in cosine of 120, I sine 120. If you don't remember, if you don't want to do it in a more clever way. 240, that's the one down here. Got the blue dot in the right place. That's 240. That's just going to be the flip version of this guy. And so that's 1 over root 2 times minus 1/2 minus I root 3 over 2. And this guy. And that's going to be the real is now positive 1/2, but the imaginary part is still negative. Boom. Okay. So, and then if you want to, you could multiply these out. If there's any simplification to be had, you really should. But here, it's not that important. This is just going to turn into 1 over 2 root 2 plus I times root 3 over 2 root 2. And then you might want to rationalize the denominators. I'm not going to go ahead and take it that far. I don't know if I'd take off points here, but it's probably good to practice actually with your roots and stuff like that. But we've basically done all the steps. And so just to review the steps, we put the original number in polar form. Sometimes that's very simple, like with a 0. We took the 6 through the magnitude. That's just a one-time calculation. And then we take the argument divided by 6, and then we add 360 over n. Here it was 360 over 6, so we're just continually adding 60s. If it was a 4th root, we'd be adding 90 degrees. If it was a 12th root, we'd be adding 30 degrees. Just going to be continually adding. Let me put that in here. Or repeatedly adding, let's say. Repeatedly add just 360 degrees divided by n, where n is the root we're taking, and here was 6. Okay, or if you want to do it in radians, 2 pi over n. And I will expect you to be able to do it in both degrees and radians, but for starters, you can just do it in whichever one's easier for you. All right.